coming to the important topic of Linux kernel module. So first of all, we need to understand what this Linux kernel module is. In Linux, there is one facility being provided where you can hot plug the drivers. Now, Linux was the first OS to have this particular functionality where you can dynamically, on the fly, load the driver, unload the driver. Typically, you remember, like in Windows and all, what we are still doing for many of the drivers, that when you install the driver, you will have to restart. Okay, when as soon as you install, you will have to restart. That was the common thing which used to happen with Windows. But Linux is the OS where you can dynamically load the driver, you can dynamically unload the driver. Those hot plug and play drivers is what we call it as a Linux kernel module. Okay, now we use this specific term module. So from this, what it emphasizes is it's it is the one which provides the modularity. Now the question comes is, why do we need this Linux kernel module? To understand this, we need to understand that our Linux kernel is a monolithic kernel. Okay, it's a monolithic kernel. What do I mean by monolithic? Monolithic means the whole kernel runs as a single executable. That means whenever you compile the kernel, for example, you see I have compiled the 6.12.54 kernel over here, and when I compile this, what I got out of this is VM Linux. Okay, VM Linux. This VM Linux is the one, is what I call it as a Linux kernel executable, and it will hold all the five functionalities: process management, memory management, IO management, network management, all those kind of stuff. And so that's why you have a single executable over here. So you basically have a single executable over here. That's why we call it as a monolithic. But now the problem is with this particular single executable, one of the biggest problem which we hit is anytime, even if I make a single, let's say my goal is to test one driver. I have written one driver, and this particular driver I want to test. So when you will be testing, of course you will have to you will have to compile this driver multiple times. You will have to add some prints, you will have to remove some prints, all those kind of things are doing. And these things you will be doing. Now let's say you basically have this driver as a part of this particular kernel image. So what you need to do is, every time, even if you change a single line of code, you will have to recompile the whole kernel. Okay, recompile the whole kernel, then load it in your, let's say, board, whatever the target board you have, reboot, and then only the things will work. Now just think of doing this every time to test your driver. It will shoot up your development time like anything. So what we are looking for is, we are looking something which can expedite our development cycles. We are looking for some modularity. Like if I want to test the driver, I don't necessarily will have to integrate over here. I should be able to test this individually. So that's where you make this driver as a module, you compile this driver as a module, and you load it and unload it dynamically at the runtime without restarting. And that's what is the kernel module is for. So hot plug and play driver is what we call it as a Linux kernel module, something which can be loaded and unloaded dynamically. Okay, and it is, why do we need it? To expedite the development cycle, to provide the modularity to the kernel. Your kernel is basically the monolithic kernel, and we want to provide the modularity. That's where the Linux kernel module comes into picture. Okay, hot plug and play driver is a Linux kernel module. Now let's see, how do we list the this particular kernel modules which we have in our system. In order to list them, what you do is you have some utility by name lsmod. Okay, we'll do lsmod, and you see these all things are the kernel modules. Okay, they are the kernel module. So What does it list? What is the size, whom it is being used by currently, and what is the name of it, name of the module, size, and whom it is being used by. So all those kind of things are being provided over here. Okay, so cdc ether is one of the driver kernel module used by one guy called Rindis host. So listing of the module is being done with the help of lsmod. Now another utility which we have got, which as I've been telling you, that driver can be loaded and unloaded, or I would like to say module can be loaded and unloaded runtime on the fly. So for that, we have the utility by name insmod. Now insmod is the one which will be dynamically loading the driver. So typically your driver module, I will use the term kernel modules. When I say kernel modules, that means they are separate images. Okay, they are not a part of the kernel image. So typically it happens like you have a VM Linux which is currently running, plus there are something called .ko, kernel object. So kernel object is what we call it as a kernel module. Okay, the signature, or I can say the extension for the kernel modules is .ko. Now the next question comes is, when I want to do insmod, where do I find these drivers? Again, I will use the term kernel modules. Where will I find the kernel modules? So kernel modules will be located under the slash lib modules, somewhere at this place. So now you see in my PC there are so many kernels which are already there: 6.5, 6.2, 5.15, 5.19. So now from where should I take this particular kernel module? The thing is, you should always load the module which corresponds to the running kernel. Now, how do I figure out what is the running kernel for me? By performing uname hyphen r. So you see, currently running kernel for me is 6.8.088 generic. So that's why what I need to do is, when I go here, over here, I need to basically select kernel version 6.8.88 generic. Under this, there will be kernel and there will be something called drivers. And here you are going to see that there would be lots of .ko files. Okay, it's not able to access it. I will be showing you like this. So you see there are lot many .ko files. This .ko is the one which is a kernel module which can be dynamically loaded and unloaded on the fly. So now I'm going to show you one demonstration where I would like to load one driver. Let me just do one thing over here, because that's an interesting case which I would like to cover. It's already loaded, so I don't want to. Yeah. So now what I would like to do is, over here, we have seen the path of this. I'm going to net USB. There is something called Rindis host, remote network, uh, and remote network device, something like that. It is. I want to basically load this. So let me just try loading this stuff. Now, when I try to load it, using the insmod, remember you need the root privileges in order to load it. You can't load that as a normal user. That's not allowed, because you need the root, because it is something which should be done by the privileged admin guy. So you see, as soon as you do this, it gives you some error like unknown symbol or something like this. So what this unknown symbol is, why we are getting this particular error as unknown symbol? As we understood that your drivers, your modules are .ko. .ko means kernel object, kernel object, which in a nutshell is nothing more than the object file. Object file. object file which is .o. And what do I mean by .o? .o is something which is not linked. Something which is not linked. So if you are aware of the process of this compilation process, if you are aware of what happens in this case, the first thing which comes into picture is preprocessor. Then it goes through the compiler. Then it basically goes through something like assembler, and then it goes through a linker at the higher level. These are the things involved. So preprocessor, you typically get those header files and all those .h files and the macros being replaced. And then in the compiler, the output of the compiler, let's say you have a GCC compiler, the output of that will be .s file. From the .s file, when you pass it to the assembler, what you get is basically .o. So when you are having a KO file, you are at this stage. That means the linking is not performed. If the link, so now what does the linking does? Linking connects, or I can say maps the callee to the caller typically, or I can say it basically maps the caller to the actual definition. Okay, actual definition of the call, or let's say if there is any global variable, global external variable, so it basically resolves the symbols. It makes sure that whatever calls you are making, this is where this particular function is defined. It finds out the definition for that. So when I do generate this call .ko, it is not linked. And when I try to do the insmod, at that point of time, we are trying to dynamically link. That means we are going to connect the symbols, that means the calls, whatever function calls we are making with the definitions. Okay, definitions. Now, in our case, what has happened is when I'm doing this, it is saying unknown symbols in the module. That means it is trying to invoke some function calls. It is trying to access some variables or something like that, which are not defined. Okay. So what you are doing is basically you have got the kernel. Okay. We have got the running kernel. Let's say VM Linux image, which is running. And dynamically, when you are loading it, when you are basically loading your driver, let's say Redis host in my case, what I'm trying to do is I'm performing a dynamic linking at this point of time. Linking. So what happens is, let's say it is invoking a call by name ABC. It is invoking a call by name ABC. This ABC, we are expecting that it would be defined in this running kernel, running image of the kernel. That means somewhere in the RAM, this function definition ABC should be there. But the problem over here is when Redis host tries to load, the symbols are being looked up for. These symbol, there are certain symbols which are not there in the running kernel, and that's where the problem we are got. So problem statement is clear.
Yes. Yes, sir.
Okay. Okay, great. Now this is, I can say, part of information we are getting, but what about the detail? What about something like from here I can't actually solve the bug, like what it is looking for. We don't have that information. Now in Linux, what happens is typically in the Linux kernel, there are something called the foreground message. You have something called the log labels, like whatever is the error or critical thing, you put it in the foreground, but avoid cluttering the screen. Whatever detailed information you want, it basically goes into the log buffer. So in the basically we have something called the log buffer in the user space. Okay, that means we will have to look into the log buffer, kernel log buffer. It's basically a kernel log buffer which is accessible to the user space, and we can access this kernel log buffer with the help of dmessage. Dmessage means looking into the kernel logs. Whatever the kernel, the information it passes to the user space, you can look into that particular thing using a dmessage. Now, what I will be doing is I will be just printing last 10 messages which are coming into the from this particular log buffer. So let's see. So from here you see Windows host, whatever we are trying to load, it is missing on these symbols. That means USB net TX timeout, USB net suspend, USB net stop, CDC bind. So all these are the symbols which we are missing, and that's why it is saying it is unable to load. Okay, that dynamic linking is failing. So here comes the problem. I have the kernel image which is running over here, and this kernel image doesn't have the symbols which this guy is looking for. That means I can't load this driver. So now how do I go about loading this driver? Because eventually I need it. It's a .q. So these symbols, then you are going to get it from another module. That means before loading this driver, this kernel module, it has a dependency on another .ko file which we need to figure out. So how do we figure out that dependency? What you do is, one of the simplest ways, if you have the source code, just do the grep. You will be able to find out the symbols. Another thing is, let's say if you don't have the source code, what you do is you take this particular symbol, and what we will be doing is over here we'll be doing a grep of this stuff into this particular. So what I will be doing, I'll take this symbol, come here, okay, and inside the lib modules, and whatever my kernel was 88, I'll go there, kernel drivers. Typically you will find that symbol here. Let's see. So does it list? Yes. So it gives us the idea that this guy is there, this guy is there, this guy is there, and this guy is there. So now it is a binary information, right? So it is basically providing us the binary information. So all those things again are something which are using the symbol. If you go into the symbol and all those kind of thing, you will see that these guys are just the users. The provider will be one of these, one of these over here. And one thing, the way you can guess is, starts with USB net underscore. So from here, typically you see we have something called USB net. Again, there are other ways also. I'm showing you one of the way. Typically, what you can do is you can use the nm command. From the nm command, you can find out whether that particular symbol exists or not. Okay, or else you best way is go to the source code and figure out whether that symbol is not there. There is another way out where you basically can uh, find the symbols in your uh, module sims, something like that. Some file is there where you will be able to find those things. So this is one of the way. Again, there are other ways also to figure out this particular thing. So now I have a USB net. What I will be doing is, this guy needs the help of the USB net. So let me just go and load the driver net USB net.ko. So it will prompt for the password. I'll put it. But now again I get the error. So unknown symbol. That means even USB net is dependent on something. Okay. USB net is also dependent on something. So let's again do dmessage and tail minus n10. So it says I'm dependent on something called MII. So again, the same way you will follow, and what you will are going to do is over here you will be finding something called mii.ko. Let me load it. No error message. That means it has got successfully. So how do I list it? Whether it has got into the kernel successfully, lsmod and head -5 for instance. So you see it has gone through. Now what I will be doing, I'll be loading the usbnet.ko. This also goes through. I have got the USB net. I have the MII. This MII is being used by USB net. So till this point, the things are fine. Now let's go to our end goal. I want to load the Redis host. So let me just try doing this. So when I do this, this guy is still crypts. That means there are other symbols also on which it is dependent on. So again, I will do dmessage, dmessage, and what I will be finding, it is looking for something like CDC related stuff, USB net, CDC, or something like that. So again, you will do the grep and find it out. You will find there will be something called CDC ether.ko. Okay, I'll do the insmod of this. Goes through. If I do the ls mode, we have got CDC ether, we have got the USB net, we have got the MII. And now let's try loading our final driver, which we are looking for. It goes through. So if I now look into this dependency chain, this is how it looks like. MII is being used by USB net. USB net is being used by two guys, CDC ether and Redis host. CDC ether is being used by Redis host. So you see, this is the dependency chain. And the process, or I can say whatever we have seen over here, where one module is dependent on another module for the functionality, we call it as this as a module stacking, one module's dependency on the another module. And this module stacking can be very deep. Right now we saw just 3 or 4. It can go to 10 levels, or it can be something like a tree like dependency. This guy dependent on this guy dependent on this, and all those kind of things, and can become very complex. Okay, till this point the things are clear.
Yes, sir.
Okay, great. So now the problem comes is like, see, all these kind of dependencies, if I have to figure out, it will become very complex. Like every dependency, find the symbol. Does kernel provides me, or the Linux provides me me with any facilities where I can dynamically figure out the dependencies? That means like automatically figure out the dependencies and load those particular things. And that's where you have something called mod probe. Okay, so what I will be doing is, let me just unload all of these things again. Okay, I will just show you how does it looks like. Now you see none of the drivers there. Whatever the modules were there, they all have been removed in one go. And now what I will be doing is, I need to just do mod probe. You don't need to go to the path as well. Okay, you don't need to go to the path. I will just do Windows host, just a single thing. Okay, so do Windows host, it goes through in one go. And when I do ls mode, you see all of them have been automatically brought into the kernel. When you try to load the Redis host, it basically figured out, okay, this guy has a dependency on USB net. Okay, let me load the USB net. Okay, now USB net has the dependency on MI. Okay, let me just load this thing. Now again, Redis host also has the dependency on CDC ether. Okay, let me just load that CDC ether. So all those things happened automatically with the help of this mod probe utility. So that's the magic of mod probe. Typically, when you have that level of dependency, mod probe is a preferred mechanism to load the driver. Okay, and this basically figures out the dependencies automatically for you, and it will load everything for you. Okay, so that's a usage of mod probe. Insmod will just try to load a particular driver. Mod probe will figure out the dependencies and it will load the driver. Okay, so this is about all the commands: lsmod, insmod, rmmod, and the mod probe, which I think I have not listed over here.